Hello everyone, welcome to today's webinar. We will wait for a few minutes, then we will start. Over to you, Raju.
Hello everyone. I welcome you all to this webinar. Uh, Today's webinar is about what's new in multi-axis milling in SolidCAM 2025. As you can see in my screen, today's agenda is that we will see some of the features that were added in the multi-axis machining, and we will see some enhancements or new features added in the machine control page of the operation. And we will also look at the new selected surfaces boundary that is introduced for rotary machining multi-axis jobs. And uh, and another feature that was added to the geodesic milling, it's about the priority of boundary pass. We'll go to the slides. So we have added a drive curve, user-defined curve definition when the pattern is set to morph between two curves in the wall finishing of multi-axis machining job. You can see on the right side image. Previously, the toolpath was created with the automatic, and now with the user-defined curves, the toolpath is much more clearer, and toolpath is created as expected. See, this user-defined curves pattern is basically added for wall finishing strategy. It's not for floor finishing. Now you can have possibility to morph toolpath with the user defined curves when the automatic drive curve doesn't give a good result of the toolpath. So when automatic curve generation fails, that let's say for example we have on this image the surfaces have unequal non-parallel edges. So when these surfaces has to generate a morph kind of a toolpath pattern, uh, you know, um, since they have unequal and non-parallel edges, SolidCAM struggles to find smooth morph between top and bottom edges. basically which results in distorted or incomplete toolpath, or I would say unexpected toolpath. So when working on this kind of surfaces, user defined curves works as expected because the toolpath pattern is in the programmer control. By manually defining the drive curves, the user can specify exactly which edges or guide curves should be used for for creating a morph kind of a pattern, and this removes ambiguity from the software's automatic morph pattern calculation. Let's see the toolpath in SolidCAM. Let me open the path. I have chosen a part where the existing automatic morph between two curves fails, and we can use the new functionality where user can define the drive curves manually. So I have this violet color surfaces to be machined. I will launch multi-axis machining, and I will choose wall finishing technology. And if I go to geometry page, to define a wall finishing job, uh, there are some pre-requirements that we need to define a floor surface and wall surfaces. Wall surfaces are nothing but the drive surfaces on which we are going to do the machining. So let me select the floor surface. This is my floor and wall surfaces. So as these surfaces are indicated by the color, I will pick from the model, find faces. So all the surfaces are selected automatically based on the color. Uh, I will select the tool, and my tool would be 10 ball nose. Don't need a constant boundaries. Since the part is huge, I will stick to the 0.1 cut tolerance, and I will use maximum step down of 5 millimeters. And tool axis control, rest everything, I'll keep it as it is, defaults, and I will just hit the calculate button. So here you can see the SolidCAM created a toolpath precisely as defined, because the SolidCAM creates or basically extract the boundaries of the surfaces uh, and create a morph pattern. So in this case, the automatically extracted curves doesn't propagate correctly, and the pattern that is created is not basically accepted. So I'll just copy paste this operation, and I'll go to geometry, and in the drive curve definition, instead of automatic, I will choose user defined curve, and I will select the top curve and the bottom curve. So this is my curve. This is my curve. If you look at the curve name, you see the curve name is derived, by the job name and the strategy and the geometry name. So this way you can, let's say for example, if you have hundreds of operations in the tree, and you want to use this contour on the other operation, you can easily find out by the name of the geometry. And my second drive curve will be the floor surface. Yeah, this is my second curve. Okay, I don't have to do anything. I can just, recalculate the toolpath. So now the pattern, internally calculated between the user-defined curves. So now you can see the top curves are aligned with the top drive curve, the first drive curve, and the bottom curve, the bottom passes are perfectly aligned with the bottom drive curve. So this is how you can create a toolpath using user-defined curves. You have a more flexibility, especially in the mod between two curves pattern. We'll go to presentation and see the next slide. So here we have added another functionality. It's called machining order. In the toolpath parameters, if you go to sorting tab, we have introduced a new parameter called machine by. This has two options, regions and lanes, which allows us to choose a sorting method for the wall and floor finishing strategies. These two methods are available: sorting by lanes or regions. Uh, Basically, the topology of the generated toolpath usually consists of multiple contours, like you can see on this surface. We have multiple contours on the drive surface. When the toolpath is generated on a surface with multiple areas, it would be a good idea or preferable to machine all the regions independently instead of machining it or by lanes. When you have gaps or you have independent areas, it is preferable to machine them independently. So when the passes are sorted by lanes, you can see on the top image, those gaps are closed by software automatically, and consider the overall area as one region, and the SolidCAM machines them in one continuous path. So when the passes are sorted by regions, so each region is machined successively. You can see on the bottom image. These new sorting methods, increase machining efficiency and reduce linking movements. And as you can see on the top image, when the machining is done by the lanes, the machining time, the cycle time, total cycle time is coming around 20 minutes. The same toolpath, the machining is done by the regions, it's coming around 15 minutes. So you can clearly see the difference in the cycle time itself, and it also helps us to improve the surface quality and also to reduce the tool wear. Now let's see the toolpath in SolidCAM. Let me open a different part. So here I have a part. This is aerospace structural part. I want to machine this area. This is it's a deep cavity. I will launch multi-axis machining wall finishing. So I will Pattern, I will set it to parallel to curves. My floor surface would be this one, and my wall will be this surface. And I will choose 10 ball nose, and levels I don't have to change anything. And again, I will keep it as it is. I'll modify the step down to 5 millimeters. And if we go to sorting, this is the new group introduced in the sorting tab, machine by lanes or regions. Let's see the toolpath using the lanes. So this is the toolpath. Uh, if you carefully look at the toolpath, you can see that this gap is automatically closed by the software because machine by is set to lanes. So these gaps is basically closed internally and internally by the SolidCAM, and the whole surface is considered as one region, and creates the toolpath. And if you look at the look at the toolpath in the gaps, so this is not the toolpath pass anymore, this is a link. Okay, so software SolidCAM creates links between those two passes to connect it continuously. Now the feed rate would be of this link is of the cutting feed rate that we defined here, and the blend spline feed rate is also defined here. If you want, you can also increase it, because since this is a non-cutting move, we can definitely increase it further. Now I'll copy paste this toolpath, and I'll go to sorting tab and change it to regions. So the toolpath calculation is completed. If you look at the toolpath now, until this distance, it is separated and machined it, individually. Now let's see the simulation. So this is one region, and defining the regions is purely depends on the software. We cannot tell the software that this should be done first, or and left side should be done first, or right side should be second. And this sorting is purely decided by the software when the regions is selected. Okay, let's move further. We'll go to presentation. So Another parameter, another functionality has been added to the multi-axis machining. Uh, it's added for a wall and floor finishing for both strategies. Uh, Tilt range. The tilt range basically limits the tool path, between the, two angles starting from the tool path slice normal vector. For example, imagine two cones with the different opening angles, for example, W1 and W2. The tool axis direction is enforced to be between these two cones, and the orientation of the cone is currently based on the rotary axis of the machine. Um, with this limits, we can easily avoid the machine tilting limits. You can see on the left side image, when the limits is disabled, you can see the tool is coming, looks like the tool is coming from the bottom. Okay, so in this case, I'm definitely sure that we will, the spindle and the bed might get collided. uh, and when the limits are applied, you can see on the right side image, you know now the tool is not tilting, going beyond these limits. And how this limits are calculated, it's simple. This is my z axis. Let's say, for example, this is my rotary axis, and you can say uh, this is 90-degree, right? And if I draw a line one more here, and you can see, and this is my 0 and this is my 100. Okay, usually this is 90, right? And this will be my 100. So the tool will be enforced to be between the 0 and 100-degree. Now let's see how it works practically on the part. We'll go to SolidCAM. Uh, Let me close this part and open a different part. So I have a part here uh, on which there is a pocket in the internal radius of the part. I want to machine this area. Okay, I will launch multi-axis machining, wall finishing again, and I will go to geometry and define my floor surface. So floor surface is basically, is the surface by which, the tool will be normal to that surface. And my wall surfaces will be the adjacent ones of those of the floor surface. So when I want to, select multiple surfaces, I prefer to go to CAD selection and select the floor and say select neighbors, and I will add select the not needed surfaces. So this way I can, quickly select this multiple surfaces. So I will select the tool uh, and yeah, tolerance, I will keep it to 10 microns. Step down is okay. Tool axis control. Uh, I want my preferred to be 40 at 40 percentage of the cutting length of the tool, and minimum should be 20, on the 20 percentage of the cutting length, and maximum I will leave it to 100%. So how these values are calculated is basically, let's say for example, this is my tool and this is my radius. Let's assume this is uh, this is the cutting length. Okay, so how this value is calculated? So this is 0 and this is 100. Okay, somewhere in the middle is 50. Okay, and this is a percentage. Okay, so when you say 10%, So it's somewhere comes around here. Say 20% somewhere coming around here. Okay, when I say 100, so it will exactly at the end of the cutting length of the tool. Lead angle, I will leave it as it is. First, let's create a toolpath without the tilt limits. I'll just hit the calculate button. Okay, so this is the toolpath. Okay, uh, toolpath looks much cleaner. But if you look at the simulation, I will go to machine simulation. Okay, so it says cannot update the stock. This is just fine. Okay, so as we expected that there is a limit going beyond the value. Basically, the tilting axis going beyond the limit. Okay, now I want to see the simulation, so I'll say yes. I'll accept the exception just to for sake of seeing the simulation. Okay, now I'll just run the tool simulation. Okay, this is just fine. Now you can see we have collision between the spindle and the body itself. Okay, see, of course this is not expected, and how we will control this um, in SolidCAM now from SolidCAM 2025. We can easily avoid these kind of situations, and you can just enable the tilt range, and I will keep maximum angles 100. And I'll just hit the calculate button. This is my toolpath, and I will go to simulation again. It's okay. So now you can see the machine simulation is being loaded without throwing exception about tilting limits. Okay, so now let me run the simulation. You can see the simulation now. So there is the gap between the the spindle and the machine itself. So this way we can avoid the tilting limits. So it's a good option to avoid the machine limits. Now this is introduced for wall and floor finishing. So let's move forward. Let's go back to the presentation. So another functionality added again to the multi-axis machining. So now the cut order, you can you can uh, you can machine from the top to bottom or bottom to top. This might look simple but very effective, because the SolidCAM gives flexibility to the user to define the how the machining order should be. Especially in the deep cavities on steep areas, the machining bottom to top ensures better surface finish, smoother tool engagement, and it also helps us to safely safe chip evacuation. So that's why the most 5-axis finishing strategies recommends bottom to top steep regions, especially on the steep regions, while the top to bottom is more common for machining shallow areas. So I'm giving the example for mold and die application. Now let's see how this works in SolidCAM. Okay. So here I have a part. I will add multi-axis machining wall finishing job again, and I will choose the floor surface. So I have to select the multiple surfaces. So I will use CAD selection. So this is my floor surface. I will accept it. And this is my wall surface. Okay. So the reason why I always prefer to select multiple surfaces from the CAD selection is that when we are selecting the surfaces from the CAD selection is that we are actually going into the SolidWorks part only mode and part mode, uh, and taking the data and giving it to SolidCAM. So this way you can quickly select any number of surfaces. Okay, that's fine. Now I will select the tool. Okay, I will keep it to the 5 mm step down. And I will hit the calculate button. So by default, now the machining order the cut order is basically set to top to bottom. So you can see by default, the machining starts from the top to bottom. Okay. So for some reason, if you want to, change it to, from bottom to top, uh, you can go to sorting and start. You can choose bottom. Okay, now let's see the simulation. So now the machining starts from the bottom. So now you have the flexibility of choosing how you want to start the machining. Okay, good. Uh, we'll go to a presentation and see another functionality. So we have added another interesting functionality to the machine control page. Uh, uh, we have added linear axis start hint to the drop down of the start angle type. So in the start angle type, we have multiple options. So one of the new option is the provide translation axis direction. When the provide translation axis direction is chosen, we have a new group parameter on the user interface is introduced. So we have a direction and angle around the rotary axis. So what is this linear axis start hint basically does? It it will help you to give the start hint for the linear axis. X, Y, or a Z. And the angle that we give is around the first rotary axis. So this helps SolidCAM's intelligent machine control algorithm to pick start point that is within the valid machine kinematics. So you can choose linear axis. You can choose a start hint using a linear axis. Uh, that will help machine control algorithm to pick a valid solution within the machine kinematics. So usually what we used to do is until SolidCAM 2024, whenever you have this kind of limits, um, we used to handle this kind of issues, warnings using a pole handling. So sometimes the pole handling doesn't solve the issue. So what is the option? So sometimes we try to modify the toolpath. So from SolidCAM 2025, we don't have to do all those R&D. Now you have great control on the start hint. This is not part of this toolpath. It is part of post processing. When the toolpath is basically converted to the machine access values, uh, there is in between there is an algorithm, machine control algorithm. So this algorithm converts the toolpath access values to the machine access values. So in this process we have now option to define the start hint. uh, so we don't need to do R&D on the toolpath. Let's see how this works in the SolidCAM. Okay, it's being compressed. Okay, good. So here I have a part. I want to machine this slot. I will launch Sim 5 axis milling. I will stick to the parallel to curves. Okay, so this is my drive surface. Okay, I have a curve here. This is my curve. Since I want only one cut, I will choose determined by number of cuts, and I want radius to be offsetted. So number of cuts is 1. I will select the tool. Okay, this is fine, and all this rotary axis is set. So I'll just hit the calculate button. So I have a toolpath here. Okay. Now if you see the machine preview, so we can clearly see that uh, the x linear axis is going beyond the limits. Okay. So what we can do is, now if you go to machine control page, the start angle type, we can set it to provide translation axis direction. And when this option is chosen, we have a multiple options in the drop down. So you can ask the system to start in any linear axis, x positive side, x negative side, y positive side, y negative side, and you can have user defined angle. So let's see. So now with x positive, it gives I still have the limit. You can see in the machine preview the x-axis highlighted by with the red color, and even on the machine body, we have spindle is highlighted, saying that it is going beyond the limits. I will choose Y positive and Y negative. It is still. Now I will choose user defined. Okay, now let me choose 30°. I will save it. Okay, I still have the limit. Now I will choose 45°. So now you see the the tool starts in such a position that there is no linear axis limits. So this way you can you see the part is basically bigger than the machine itself, machine table itself, but still you can machine these kind of parts. So this is the capability of the start hint. You have to remember that this linear axis start hint works effectively with the force stable rotation. If you have a 5-axis machine, it also works with the smooth interpolation of rotary rotation angle around the pole. So with these two options, the start hint works in a expected manner. Good. We'll go back to presentation. And another parameter, new functionality has been added to the advanced tab of the machine control page. Retracts and rewinds. So this is the new button is added to the SolidCAM 2025. If you click on this button, we have this new dialog, advanced settings for retracts and rewinds. So basically, it provides flexibility to control retract and rewinds. Okay, you can see on this the top image on the right side, these retracts. We have this retract. So why this repositions happens in 5-axis machining? The tool may need to rewind or lift away from the surface because of machine kinematic limits. And these retracts sometimes may cause collisions with the adjacent parts if you have on the bed, machine bed. So sometimes these retracts not required. This kind of a retract may cause collisions with the other parts on the besides adjacent parts which are clamped on the bed. So you want to change those type of retracts. Previously we have no choice. We have to move the part we have to clamp the part in such a position where our repositions doesn't collide with the other parts. Now from SolidCAM 2025, you can have part any number of parts on the machine bed, and you can still create, ask the system to create collision-free links, collision-free repositions against the other parts that were clamped on the bed. So here we can, if you can see the the new dialog, you can retract the tool in the tool axis direction, and you can set it to machine limits, or you can set it to user defined value. And after tool retracting in the tool axis to the certain height of the tool axis direction, you can choose a different direction. Okay, you can choose X, Y, Z, or any user defined axis. Let's say, for example, if I choose Z axis, and for that Z axis also I can define the other height as well. So let's see how this works in the software. Let me close this CAM part and open other part. Okay, so I have a part here. I want to machine this radius. I will launch Sim 5-axis milling. Okay, I will leave it to parallel cuts. And this is my drive surface. Okay, Z axis is fine. And I will choose the tool. Okay, and my step over is 5 millimeters. I will set it to spiral. Okay, minimum angle change is all good. I'll set it to rotational limits. So now the geometry is being prepared for the toolpath calculation. And since this is the huge one, uh, SolidCAM takes some time to prepare the geometry for the toolpath calculation. And this is for the first time. If you choose the same geometry in the next job, uh, the toolpath is calculated quickly because the geometry is already there. Okay. So now the toolpath is calculated. Now, if we now let me launch SolidCAM Simulator Kinematic Mode. So if you can see the toolpath, we have some repositions. Okay, let me also show you the target. Yeah. So you see this retracts. Sometimes if let's say for example, if I have other job clamped besides this, so you might you can see that the head might collide with the other part as well. So to machine a job using these repositions, so you should have more space on the table itself. So how we can control previously until SolidCAM 2024 we try to modify the toolpath when we try to do the R&D, try and remove try and avoid these repositions. Now I'll just copy paste this toolpath from SolidCAM 2025. If you go to Advanced Machine Control Advanced tab, uh, there is a new button called Retracts and Rewinds, and if you click on that, we have a new dialog for customizing those retracts. Now the retract in the tool axis direction. Now I will set it to probably I'll say I need only 25 millimeters, okay, in the tool axis direction. And from there, I will choose another direction, and I want my tool to be retract in the Z axis. And the height should be, it's not the machine limits. You can also choose it to the machine limits. It is always a safe. Uh, and you can also choose, you can also give a different value other than the machine limits. Okay. So for now, I will choose like 150 millimeters. Okay, and I'll hit OK. Okay, I'll save and calculate. Now, if again I will go to SolidCAM Simulator Kinematics mode, you can see, this the retracts. Now, tool retracts in the tool axis direction until 50 millimeters, and then tool retracts in the you can see in the Z axis, and then we have a rewind. Okay, to see the machine simulation, let me show you the machine simulation. Okay, I don't want stock to be updated. Okay. Okay, now, okay. So I will uncheck the follow. In the machine simulation, if you want to see those retracts, you have to go to analysis and choose a tool number. So this is the basically posted toolpath, and obviously this is different from the calculated toolpath, because the toolpath that you see in the machine simulation is basically uh, uh, calculated on the machine kinematics, using the machine kinematics. Let's see the simulation. Okay, this is fine. Okay, this is fine. Okay, now if you look at this move, you see retract, there is an interpolation. Okay, so this is the interpolation, and then it, you see the until 50 mm distance, it comes with a rapid feed rate. Let me also show you the move type and the feed rate. Sorry. Okay, so now if you look at the feed rate, it is a 10,000 feed rate. And where this 10,000 feed rate is coming, this is by default in the SolidCAM. Uh, Again, it depends. Let's say, for example, if you have maximum rapid feed rate on the machine, let's say, for example, 6,000, and then it will take 6,000. Okay, and let's say, for example, if your machine has more than 10,000 feed rate, 10,000 rapid feed rate, it chooses 10,000 feed rate by default. In the future, we will have this option on the machine control page, and then you can have your own feed rate, rapid feed rate. Okay, now if you choose approach line, you can see it is still 10,000. Okay, and approach on the surface, but it is reaching 1,000. Okay, 10,000 feet, it's still 1,000 feet, right? Yeah. So but when the tool is reaching on the surface, it is taking the feed rate of 1,000, which is the cutting feed rate, and it is a good sign. Okay, and we also added another other parameters for interpolation, and also for approach and retract distances. Okay, let me open the dialog. If I go to advanced and retracts and rewinds, if you look at the rewind interpolation angle step, previously until SolidCAM 2024, by default it was a single angle step. Let's say, for example, if if the tool has to reach from this position to this position, it will do this one circle. It does this circle in one movement. Let's say, for example, C360. Okay, uh, in the new option, with this new option, you can actually break this movement by, like, for example, maybe 45 degree, or like 10 degree or 30 degree, whatever you want. Okay, so use a defined angle step. So if I put like 30 degree, okay, so it will interpolate that movement by 30 degree. And we have another set of parameter is the feed distance for approach and retract. You can see the approach and retract, previously it was set to 0. Okay, this was the until SolidCAM 2024. The tool retracts from the surface using a rapid feed rate, and also approaches the surface using a rapid feed rate. So now from SolidCAM 2025, you can use the distance, which that distance will be used as a feed distance. Okay, and cutting feed rate is applied for the particular distance. Let's say, for example, if I give 10 millimeter, okay, so approach up until 10 millimeter, it uses the actual feed rate, cutting feed rate. So when retracting, it also uses the actual cutting feed rate. Okay, I'll just hit the calculate button. Now, if I go to simulation, machine simulation, okay, I cancel the updated stock because I don't want to see the updated stock. So if I go to analysis and see the select the tool number, we have these repositions. Now I want to show you the the retract, the interpolation angle. Okay, so here you see the angle. Okay, so 211 to 180, 180 to 150. So that movement is actually broken by 30 degree. Okay, so every 30 degree we have one move. Okay, so this is how you can break this movement. And if you look at the approach and retract, of course we already saw it. Let us see it again. Okay, so this is a move type, and this is a feed rate. Okay, now so this is fine. Now if you look at, you see, until this distance the feed rate is 10,000. Okay, when tool is approaching, okay, you see it is 1,000 feed rate. Okay, again it is the same when tool is retracting. Okay, so now tool is on the surface. Okay, okay, now the tool is on the surface. Okay, now the tool should retract using 1,000 feet rate. So now you can see this distance is moved using a 1,000 feet rate, and this is retract distance. Retract distance is 10 millimeters. So this is how you can control the repositions. Uh, so this approach and retract distance actually benefits us that we can prevent the tool marks on the machine surface, and we will make sure those approach and retracts are safe, and we can also protect the tool and uh, the part as well. And then with this custom repositions, user defined repositions, uh, uh, we can say these are reliable, and they are predictable, and operator maybe the programmer can trust these motions. Okay, so that's pretty much about machine control parameters. I will go to the presentation to see the last feature. Uh, this is about geodesic milling. We have added, until SolidCAM 2024, geodesic milling creates a profile pass, but the profile pass was, machined at the beginning of the beginning of the, process of machining. Um, so there were some request from one of our customers. I think many of our customers that they want to run this profile pass at the end of the machining, after the whole pocket is machined. He wants to run one profile pass throughout the pocket, so that we don't leave up any scallops throughout that profile. Okay, and you can give the additional offset value. uh, this additional offset value, if you want to offset inside the boundary, and you have to give the negative value. If you want to create additional boundary, outside the surface, and then you have to use the positive value. Let's see how this works in the SolidCAM. Let me close this part. Okay, it's compressing. Okay. Okay. So here I have a path. Let me create geodesic machining, and I will choose the surface that I want to machine. Um, I want to create a parallel toolpath, so I will define the curve. My curve would be, I'll define by point. I'll select this vertex and this vertex, and the line is created automatically. And I will choose the tool. Since I'm using a ball nose, I will use center mode calculation method. I don't need to choose anything. Yeah, I will. Okay, I'll leave it to 5 millimeters. Okay, zigzag, this is fine. And I will go to link, and I will increase the threshold value to the 400 percentage of the step over. Okay, and I will, okay, this is fine. So you can see, we have a, nice, parallel toolpath. And if I have to apply the additional boundary, okay, so the additional boundary is applied, okay. But now, now I want to, parallel cuts to be, inside this boundary, not exactly at the center of the boundary. So what I would do is I will say internal, my tool is 10 millimeters, and the offset value will be 5 millimeters. It's a tool radius. So now we have, the tool is, the parallel cuts are inside the containment boundary, and we have a, profile pass at the end. Let's see the simulation. So we have, yes, I think it was very quick. Yeah. So now we have this profile pass. And you can also offset it internal inside. Let's say, for example, 1 millimeter, you can do that. So you have to make sure that, this additional offset doesn't go beyond the offset value. Okay. So this is how you can create an additional, offset, or I would say the profile pass, like we have in, horizontal machining of a Pro 3D HSM. So this is very helpful when you are doing a parallel kind of a machining. You might probably end up leaving some, scallops, especially when you're working with, bigger step overs. So this will make sure the profile pass make sure that, there are no scallops left behind after the machining. Okay. So I think the time is over. I think I will show you the, selected surfaces, the new boundary in the multi-axis jobs in the next webinar. I think for today, that's it. If you have any questions, you can. I'll be happy to answer.
So we have few questions. Okay.
Mhm.
What is the difference between custom triangulation and new retract, rewind?
Custom triangulation.
Yeah, difference and new retract
Uh,
or rewind.
okay. Okay. Let me open the dialog. So if I understood correct, these retracts and rewinds. So what is the difference between the existing and the new repositions that probably you might be asking? Uh, See, previously, until SolidCAM 2024, these repositions are done only in the machine in the tool axis direction. Okay, let's say for example, if I have a wall here, okay, and my tool axis is direction is like this, so it is always retracts in the same direction and does the rewind and comes back in the same direction. Now what you can do is you can restrict this distance to the certain distance, okay, in order to avoid maybe you have some collisions with some other parts over here. So you instead you can you know retract in the tool axis direction, let's say for example maybe 20 or 30 millimeter, and then you can retract in the other direction. So this is the previously we did not had an option to define this retract in the other direction. So now we have this, you can customize the way you want the retracts to be, and you can have a safe machining. Any other question?
No, I think that's okay. And we will be sharing the recording of the webinar. Someone has asked, so we will be sharing.
Yeah. Okay. So thank you very much for joining us. Uh, I'll see you in the next webinar. The next webinar is going to be about what's new in 3-axis. We have added some excellent functionalities in the Pro 3D HSR and Pro 3D HSM. And in that webinar, I will also include the selected surfaces new boundary. Thank you again. See you in the next webinar. Take care. Bye.